Okay, let's consider this small circuit. We have a voltage source here, a battery, power supply, whatever you want to call it, and three resistors. This 1 ohm resistor, 5 ohm resistor, 20 ohm resistor, and another 20 ohm resistor. Just a few things to notice beforehand. This resistor, the 5 ohm resistor, is not in series with any of the other resistors. It's not in series with them because the current passing through R1 is going to be divided among R2 and R3. We are not going to have the same current through R1 as through R2 or R3. So it's not in series with either one of them. However, R2 and R3 are in parallel. If you look here, both ends of R2 are in contact with both ends of R3. If we use the color code, we have all that area at the same electrical potential, and all of this at the same electrical potential, which says that the voltage change or the voltage drop across R2 is the same as the voltage drop across R3. In both cases, we go from green to red. Okay. Now, after we notice that, let's answer the question. Here, we are asked what is the voltage drop across the three resistors in this circuit. So we would like to find the voltage drop across each one of them. To do that, essentially we need to find the voltage drop across R1, which is going from this side that's black to the red, the voltage drop across R2, and the voltage drop across R3. We just talked a minute ago about the fact that the voltage drop across R2 is the same as the voltage drop across R3. So essentially we have to find just two of them. Now, the voltage drop across any resistor is given by Ohm's law. V is equal to Ri. In other words, the voltage drop across R1 is going to be R1 times I1, the current that's going to go through R1. Now here, we don't know what I1 is. We just know that it's going to be the current through R1. We just gave it a name. So to be able to find this I1, I'm going to have to simplify the circuit. One way to simplify it is to reduce R2 and R3 into their equivalent resistance, R23. R23, I can find it since they are in parallel by using 1 over R23 is equal to 1 over R2 plus 1 over R3. Here, since R2 and R3 are the same, so it's 2 over R2, and R23 is then just R2 over 2, which is 10 ohms. Which means that my circuit, the equivalent circuit right now, is going to look more like this. I have a 3 volt battery, and then a 5 ohm resistor, that's R1, in series with R23, which is 10 ohms. So the overall resistance that is seen by the battery is going to be R123, which is the equivalent of these two resistances that are in series. The equivalent of two resistances in series, we get it by just adding them up. In this case, it's going to be 15 ohms. So the battery is seeing 15 ohms. So we can write the voltage across the battery as equal to R123 times I1. Remember here, I1 is the same as we drew here. That's because we just replaced the 2 and 3, R2 and R3, by their equivalent. So that's not going to change the current through the circuit. So now, all what we have to do is plug in numbers. V is 3 volts. R23 is 15 ohms. And this is I1. So I1 is going to be 3 volts over 15 ohms. So it's going to be 0.2 amps. Okay. Now that we found that, we can easily find the voltage across R1 that we wrote. Let me change colors here so we can write more on this side. Okay, that we wrote here. So that's going to be 5 ohms times 0.2 amps, which gives us 1 volt. Okay, now there are different ways to find the voltage across R2 and R3. First, we can note that it's the same as the voltage across R23, or the same as the voltage across this. So then it's going to be VR23 is going to be 10 ohms times I1. So it is just 2 volts. The other way we could have found it, we know that we have 3 volts here. We dropped 1 volt here, so we are left with 2 volts at this side and 0 here. So the voltage drop across the 10 ohm resistor is 2 volts. And since they are in parallel, it's the same voltage across both of them. Okay, just as a reminder, resistors, let's go in color, resistors dissipate energy. We can find the power dissipated by a resistor as P equal to V times I. And V times I for a resistor, it can be expressed as well as Ri squared or V squared over R. Now, one thing you'd like to remember, this is power. This is not the energy. If I would like to find the energy expended by a resistor, I have to multiply power by time, just as a reminder. Now, the voltage for resistors is IR, or for any ohmic device. If I have resistors in parallel, I can combine them by adding up the inverses and then taking the inverse of that at the end. If I have, equation is for 2. If I have more than 2, I just have to add them up. For resistors in series, I just have to add up the resistances. Remember, this is opposite to what you do for capacitors. Now, one rule I would like you to remember to help figure out if resistors are in series or in parallel, especially for tricky circuits. 2 resistors are in series if and only if every loop in the circuit that contains R1 also contains R2. Okay, we'll go back to this when we apply it. The other rule, 2 resistors are in parallel if and only if, we still have if and only if, you can make a loop that only has R1 and R2, no more, just both of them. And of course, this rule for parallel and series, it's applicable to all devices, including capacitors. It's not just applicable to resistors. But remember, the laws that we use for combining resistors is different than the laws that we use for combining capacitors. Each device, we have to be careful to use the combination rules that are appropriate for that device.